we want to find a Maclauren series using derivatives. And how? Of what? We're finding the Maclauren series of this guy. F of x is equal to the sine of 3x. What's next? We need to get a bunch of derivatives. So we take our first, second, third, fourth, and fifth derivative. We see we're using the chain rule, and that's why that 3 keeps growing on the outside. So I'm getting 3 squared, 3 to the third, 3 to the fourth, 3 to the so on. We're trying to find a general term. But this is the Maclauren series. So we're going to take those derivatives and we're going to evaluate them at 0. So we go and we evaluate each one of those derivatives at x is equal to 0. So our function evaluated at 0, that's the sine of 0, which is 0. Then we take our first derivative and we evaluate it at 0. And that's how we got our 3 there, because our cosine is 1. Then 0. Then 3 to the third. Then 0. Then 3 to the fifth. What's next? We're trying to find a pattern. Oh, here we go. We're going to put it into this series. This is the Maclauren series. So we trot out a couple of terms of this Maclauren series. And there we go. That was our first term, where this came from the previous page, this came from the previous page, this came from the previous page. This came from the previous page. That's when we were evaluating our derivatives. Where'd the 3 factorial come from? It's of the form. Boom, those go to 0. So let's get rid of those terms since there's nothing in there. And we notice that we are getting a pattern here. We're seeing 1s and 3s and 5s and 7s. How do you write a sequence for 1s, 3s, 5s, and 7s? That sequence is 2n plus 1. Yeah, if you plug in 0 there, that's a 1. If you plug in 1 in there, that's a 3. If you plug in 2 in there, that's a 5. So we write it in that nice tight form, replacing everything that's changing with that 2n plus 1. Yeah, so I put a 2n plus 1 for everything that's changing, and I add the alternating part out front. That's that minus 1 to the n. What's next? Well, I need to tell you that that thing converges everywhere. And how do you find that? That's in another video.